Alright, so we got one last type of ion to talk about here, and that's polyatomic ions. And so these are made out of multiple atoms. But they still have a total charge. So they have too many or not enough electrons. Most of them are going to have too many, as you'll see in a second. And so what I'm going to do is I'm just going to list out the 8 polyatomic ions you need to know for this class. There are more out there, so this is not the comprehensive list, be aware. But these are the only ones I'm gonna hit you with. And so normally you would have to memorize them for a class, but you know, I have no way of stopping the notes from being, or the exams from being open note, so you know, just be aware of what they are. Alright, so first we have sulfate. Okay, and so this is SO4 2-. So it has 1 sulfur, 4 oxygens, and they're all bonded together, but they have a -2 charge, so they are an ion. Alright, and then next we have nitrate. And I'm just going in the order that they are listed on the Moodle page to help you out as well. And so this is NO3-. So it has a -1 charge, nitrogen with 3 oxygens on it. Alright, and then we have carbonate. If you're like thinking that sounds like something in Star Wars, you're close. Carbonate is actually a very similar ion. So it's CO3 2-. And then we have bicarbonate. Which is HCO3-. So this is an ion that's in baking soda. So baking soda is sodium bicarbonate. And these are actually ions that are going to be incredibly important later on in the class when we talk about how the pH of the bloodstream is maintained. So they're not going away, and they come up quite a bit in A&P as well. Next we have phosphate, which is an incredibly important biological ion. If any of you garden, you often have to make sure that you have, you know, phosphate in your fertilizer, things like that, because it is very important to life. Alright, and then we have acetate, which is C2H, how many H's are there? 3, O2-. Alright, and then we have, excuse me, hydroxide, which is OH-. And then we have ammonium, which is NH4+. So there should be 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that is the list for the class. And so what do you need to know? Well, the name tells you the ion, so you got to know the formula and the charge. And we'll talk about why in a second, because guess what we're going to do? We're going to write, you know, names and formulas with them. So what we have here, you know, this is a covalently bonded structure, but it's going to go into an ionic compound because it is an ion. So what you have is a certain number of protons here, and then you have 2 more electrons than that in the whole structure. And so the whole thing, it basically acts like, you know, if you have like a chloride ion, well, this is like a chloride ion, it's just bigger, you know, like nitrate, you know, has the same charge, it's just much larger. And so in terms of ionic behavior, it's just an anion with a -1 charge. This is an anion with a -2 charge. So one cool thing about these is that this is the name of the ion. We don't need to change any endings or anything like that. So, you know, for example, if you see something like Na2, oh, make that 2 a little bigger, SO4, what do we name that? Well, guess what that is? That is the sodium ion. So sodium SO4, that's sulfate. So for polyatomic ions, we don't change the ending. We just leave it alone. So as long as you know what the ion is, it's actually easier. You know, KNO3. Well, what's K? It's potassium. And we have nitrate. So NO3 is nitrate. Okay. One pitfall here. So remember I said if you see polyatomic ions, it's ionic compound. Yes, that is true. And the reason I say that is, what if we have something like this? Well, it looks like that's a nonmetal, that's a nonmetal, that's a nonmetal. So this should be covalent, right? Well, this is an ion right here. So this is not a covalent compound. It is an ionic compound. So watch out. That's the trick. You can write an ionic compound that's actually made out of all nonmetals if you use ammonium. You'll notice all of these are anions except ammonium is a cation. So it's the only one I can sneak in place of a metal. So just a heads up on that. And so what we would call this is ammonium, because again we just named the ion. The name of that ion is ammonium. How do you know that? It's in the list. Ammonium chloride. Alright, so we'll do some more examples, another page examples here in a second, but this is the list you're supposed to know again. So the formula with the charge paired with the name. You're supposed to know all that in a total package. I would always, when I teach this in class, I write them on the board, and I always joke that polyatomic ion day is the leg day of biobonds. Everyone hates it, but you can't miss it, or else you just look like you're walking around on a chicken. So you guys don't have to memorize these, but I encourage you to be familiar and have a plan at least. Alright? So, we went from formulas to names. Let's do the opposite. Let's go names to formulas. So let's look at, how about calcium phosphate? Alright. Well, what's the calcium ion going to be? Periodic table back in the picture. +1, +2. Alright. So Ca2+. It's not a transition metal, right? So we can use our periodic table. Be very helpful there. And phosphate, as you've already memorized, is PO4 3-. What do we do now? That's right, same thing we've been doing the whole time. Doesn't change. Ca3. Now here's the trick. I got to put this PO4 in parentheses and then say there's 2 of them. So let me make that 3 a little larger. There we go. So Ca3, and then this is saying that there are 2 PO4s. Alright? So that means there's 2 phosphorus and 8 oxygen in here. But we treat this whole thing as a prepackaged unit. And so to show that there's 2 of them, we use parentheses. Now if there's only 1, like I had on the last page, we don't need parentheses. So, as always, we are just lazy and avoid doing more work until we have to. Now we have to for those parentheses when we have more than 1. Alright, so what about magnesium hydroxide? What's that going to look like? Well, same thing we did before. Magnesium, Mg, alright. And it's a 2+, we get that from our periodic table. Dumps 2 valence electrons. Hydroxide, as you've already memorized, clearly. It's been 9 minutes, is OH-. Alright, do the switch. We get 1 Mg and 2 OHs. So any polyatomic ion, even whether or not there's any other subscripts in there, we do that. Because if we write this, well that kind of looks like water, right? So we don't want to do that. We don't want to do that. We do the parentheses. Because if we don't have the parentheses, it looks like there's 2 hydrogens and 1 oxygen. This is showing us there's 2 of everything. Alright. So let's crank it up a notch, alright? Let's bring a polyatomic ion into this and combine it with a transition metal. Just get it all out there, alright? So we'll have chromium 3, so not Aaron Brockovich famous chromium, but it's, you know, the Daniel Baldwin of the chromium family, okay? I think there's a Daniel Baldwin. If not, it just proves my point even more. Alright, so we have chromium 3, we need a polyatomic ion. How about, what have I not used so far? Carbonate. I don't know how stable this would be, but sure. Chromium 3 carbonate. Okay, well, pull up periodic table. Uh-oh. We know it's CR. That's it. That's all the periodic table is going to help us with. So how do we know the charge? Remember? Roman numeral tells us. Alright, carbonate. CO3, 2 minus. How do you know that? Because it's polyatomic ion, you memorized it. That's how you know that. Alright, then we just do the switch. We get CR2, and I'm going to need parentheses here, so CO3, 3. That would be my formula. Now let's do one more, and I'm going to give you a formula, and you got to name it, alright? So, I think this would be kind of the most difficult kind of problem you would encounter. Cu OH2. You have a transition metal that can have multiple charges mixed with a polyatomic ion, and you've got to name it. I think this is the peak of difficulty for these problems. So once you get to the point where you can do this comfortably, you're golden. You've got it down. So, what do we know? We will always know the charge of our anion because we look at our periodic table and we go copper. Oh, it's a transition metal. We don't know the charge. But I do know that it's Cu now. Could have sworn it was Co because those are the first 2 letters in copper, but apparently it's, you know, Cu. Which I guess we knew anyway, it was in the formula. But we don't know the charge. So we know it's going to be copper something, and then OH is hydroxide, right? That's their polyatomic ion, hydroxide. And we know that this is OH with a -1 charge. Okay? Because you've memorized it. I don't know if I've emphasized that enough yet. I know if I just say it enough times, it sinks in. That's how memories are formed. People telling you to memorize something. Alright. Now, what do we do? Remember we do the little trick. So our charges are going to add to 0. I've got 2 -1s plus something gives me 0. So that means my something is +2. Which means I have copper 2. So that is as hard as it's going to get. And so if you're a little bit lost there, guess what? You get free instant replay. Just click back over and over and over again. Try to work through it on your own. I'm going to humble brag now. I remember teaching a class once, and there's a student who was struggling, and I was talking with them, and they said, well, you just made everything look so easy on the board. And it's like, well, yeah, I've been doing this a little while. You know, I've gotten a lot out of my business degree. So, someone's going, wait a minute, I'm learning chemistry from a guy with a business degree, and somebody's like, this guy lies all the time. I don't trust him. One of you has the right instinct there. I won't lie about the chemistry, but I might lie about my chemistry qualifications. Just a heads up. But anyway, I might make it look easy, but there's a big difference between me doing this in a recording and you doing it from scratch. And so again, you can just start pulling stuff off the periodic table. Take a cation, mix it with a polyatomic anion. Take a transition metal cation, mix it with a polyatomic anion. Even if you don't know what the charge could be, just make it up, you know? Just practice. Have fun with it, you know? Everybody will be over there playing beer pong or something like that, and you'll be drawing ionic compounds. And who's winning that party? You. That's right. Because that's got to be a coronavirus vector and a half right there. So, someday someone's going to watch this video and not know what I'm talking about. But you all know right now. Okay, so that is the whole story on ionic compounds. You should be able to name any ionic compound with the polyatomic ions I've given you. You should be able to write a formula for any ionic compound, including ones that have the polyatomic ions that I've given you. I will not go outside of the 8 that I listed. But now, the whole periodic table is fair game. Now, everything that's a metal will always be a cation. Everything that's a non-metal will be an anion. I'm not going to break that. Nature is a jerk. That doesn't always happen. People really like to bully nature too and make weird stuff happen. But in our class, we're going to keep it simple. Pluses, minuses, all right? And then you got the polyatomic ions on top of that. And that's the whole picture with these. So can you write a formula from a name? Can you write a name from a formula? That's the big skill in this section. And hopefully I've given you the tools to be able to do that confidently. If not, you know, hit up the forum, email me, visit my video office hour, whatever I can do to help, just let me know.